Hello guys, today we are going to learn physics chapter 2, physical quantities and measurement. Before I start this chapter, I need to tell you something that I'm not going to finish this chapter in one video. The whole chapter is going to be divided into several parts, and this is our part 1. And today we are going to learn about few topics, and the rest of the topics will be learned later on. Okay, so let's start with our first topic without wasting any time. Okay guys, so our first topic is density. Now what is the definition of density? Density is defined by mass per unit volume. If I go with the mathematical expression, density is represented by D equals to mass per unit volume. Now if I talk about mass, what do you know by mass? Or what do you understand by the term mass? Mass is nothing but the amount of matter present in an object is mass. Now if I talk about this pen, as you can see, the pen is made up of plastic, so the amount of plastic present in this pen is its mass. Now let's talk about the unit of mass. What is the SI unit of mass? We know the SI unit of mass is kg, right? Now let's talk about volume. By definition, we can say the space occupied by an object, the amount of space occupied by an object is its volume. Now what will be the SI unit of volume? The SI unit of volume will be meter cube. Now if I ask you how the volume is meter cube of a solid object, then we have to draw a figure. Now let's draw a cuboid. Now if I draw a cuboid over here, see, this is our length, which is L, this is our breadth, which is B, and this is our height, which is represented by H. Now in order to find out the volume of that particular cuboid, the formula of volume is length into breadth into height. So maybe let's say as we are talking about the SI units, what would be the unit of length? Meter. Breadth, meter. Height will be measured in meter. So when I am writing the units, it will be meter into meter into meter. Let's say the length is 5 meter, breadth is 2 meter, length is 1 meter. Let's forget the magnitudes. Let's talk about only the units. When I'm writing the units only, here it becomes meter cube. That is how the the SI unit of volume becomes meter cube. If I write this over here, kg per meter cube, it becomes the unit of density. The SI unit of density becomes kg per meter cube. Is that clear? Now if I talk about the CGS unit, of density, kg becomes gram and meter becomes centimeter cube. So gram per centimeter cube is the CGS unit of density. Okay. Now as we have understood, for solid object the unit becomes in SI is kg per meter cube. But for solid, this is for solid. Now what about gas and liquid? Do we measure the volume of liquid in meter cube, or do we measure the volume of gas in meter cube? No. So the density for gas, the unit of density for gas would be kg per liter, and for liquid it is same, which is kg per liter. As in SI, the unit of volume of gas is liter, and so as liquid. Okay, this is the difference between when we measure the density of solid and gas. Okay, so this is our second topic, that measuring the volume of an irregular solid. How to measure the volume of an irregular solid? Irregular solid means what? Irregular solid means which does not have any particular shape. Like if I have a solid object like this, like in the shape of a cuboid, you can easily measure the volume with the formula, which is length into breadth into height, right? But if we have a solid object which has no proper shape, which looks like this, then how will you measure the volume of that particular solid? In order to measure the volume of that particular solid, we need three things: this solid, a string, a measuring can, which is also known as Eureka can, and some water in it. Okay, now let's check how we are going to measure the volume of this irregular solid. Suppose when the water is poured in this measuring can, suppose the level was at V1. Now we have to tie this solid with this particular string, and when we are lowering it, when the solid is over here, the level of water rises up to a certain level. Suppose it rises up to this level, and let's say this is our V2. Now as you can see, V2 is obviously greater than V1. And you know why the water level rises up? Due to this particular solid, because inside the water this particular solid has occupied some space, right? And we know by definition of volume that when a particular solid occupies some space, that is its volume. So this is the region where this volume takes place. So if we subtract the final volume, so if we subtract the initial volume of water from the final volume of water, we will get the volume of that irregular solid. Suppose, let's take an example. Suppose V1 is at say 5 liter and V2 is at say 11 liter. So the volume would be 11 minus 5, that means 6 liter. Now you will ask me, sir, this is a particular solid and the volume of solid cannot be in liter. Okay, that is not going to be a problem, because we know that the volume should be in meter cube in SI, right? So there is a relation between meter cube and liter. Okay, and the relation is 1 meter cube equals to 1000 liter. So with the help of the relation, we can convert this liter into meter cube, and by this process you can find the volume of this irregular object. Clear? Now let's take the numerical example which is given in your book. A measuring cylinder is filled with 50 ml of water. Okay, the measuring cylinder is given with 50 ml of water. So 50 ml of water is our initial volume, which is V1. So V1 is 50 milliliter. Okay, and a solid with mass 16 gram is then lowered into the cylinder. Now what is the mass? Mass is 16 gram. 16 gram, okay, there is a mistake, it would be in gram. Okay, 16 gram is then lowered into the cylinder. The water level rises up to 58 ml. The water level rises up to 58 ml. That means our final volume becomes 58 ml. Okay, so as we have learned earlier, so the volume is the final volume minus the initial volume, right? So the V becomes 58 minus 50 ml, which is 8 ml. Now we need to find the density of the solid. The formula of density is what? Mass per volume. What is the mass of that solid, which is 16 gram, by V. V is what? 8 ml. 8. So the final answer becomes 2. This was gram and this was in milliliters. So the final answer is 2 gram per milliliter. Clear? Now this is going to be the density of that particular solid. Now let's take the second example which is given in your book, and that is a child finds the mass of an iron nail to be 7 gram. That means mass is 7 gram. He then takes 10 such identical nails and gently places them into a Eureka can filled with water. The water overflows and is collected in a measuring cylinder. The reading noted from the measuring cylinder is 9 ml. That means the amount of water which overflows is 9 ml. Clear? That means for 10 nails, 9 ml of water overflows. So for one nail, 9 by 10 ml of water overflows, which is 0.9 ml, right? So for one nail it is 0.9 ml. That means from here we can say the volume of one nail is 0.9 ml. Now we need to find the density of the iron nail, right? So density is mass by volume. So mass of one nail is 7 gram and volume is 0.9 gram. So when you calculate this, you will get 7.8 gram per milliliter. That is your answer. Okay, now we have already talked about how to measure the density of solid objects. Now if I talk about how to measure the density of a liquid, let's say we have a liquid and the volume of the liquid is say V. Now in order to measure the density of liquid, we need two measuring cans. Suppose this is our first can and this is our second can with that particular liquid poured in. Now when this can is empty, let's say the mass of that empty can is m1, and when the liquid is poured into this measuring can, the mass becomes m2. Now m2 is obviously greater than m1 as m2 contains the mass of the can and the mass of the liquid. So can you tell me what will be the mass of the liquid? The mass of the liquid is going to be m2 minus m1. This is the mass of the liquid, and when we know the mass of the liquid and when the volume of the liquid is given, then it is very easy to find out the density. That is m2 minus m1 by v. This is the process how you are going to find out the density of a given liquid. Okay, so now our next topic is relative density. So as the name suggests, relative, that means it is going to be some ratio. Now let's see what is the ratio. So if relative density is represented as RD, so this is the ratio of density of any unknown substance by density of water at 4 degree centigrade. So the definition of relative density is, this is the ratio of the density of a substance and the density to the density of water at 4 degree centigrade. Now why at 4 degree centigrade? Why at 4 degree centigrade? Why we are not taking any other temperature? Why particularly at 4 degree centigrade? Because at 4 degree centigrade the density of water is maximum. That's why density of water at 4 degree centigrade is taken. Now let's talk about the unit of relative density. What would be the unit of relative density? See, density of a substance in the numerator and density of water in the denominator. So the unit of density in the numerator and the unit of density in the denominator, that means it becomes unitless. You know why? Because then density would be what? Kg per meter cube on numerator, and kg per meter cube also in denominator. That means we can cancel it, there is nothing. That means relative density is a quantity which is unitless. Okay, so you need to remember this, guys. Relative density is unitless. Now this is the reason. Now if we have a substance which has same volume of water when it is at 4 degrees centigrade, suppose this substance has a volume which is equal to the water volume at 4 degrees centigrade, then how we are going to calculate the relative density? So as we know, relative density is the density of substance by density of water at 4 degrees centigrade, right? Now as we have studied earlier, density of substance can be written as mass of substance, mass of that particular substance, and let's say volume of that particular substance. The ratio of mass per unit volume is the density of that substance. As the volume is equal with the water, so that's why I'm writing only V. And for water, mass of water by volume. Now if I calculate this, it becomes ms by V into V by mw. We can cut V from here and it becomes mass of that particular substance to the mass of water. So if we have any unknown substance which has volume V which is equal to the volume of water at 4 degrees centigrade, then relative density becomes, then relative density of a substance can also be defined as the ratio of the mass of a certain volume of a substance to the mass of the same volume of water at 4 degrees centigrade. Let's talk about water. So as I have told earlier that density of water becomes maximum at 4 degrees centigrade. How much? So at 4 degrees centigrade, the density of water is, okay, let me change the pen. The density of water is 1 gram per centimeter cube. This is in CGS, and in SI it is 1000 kg per meter cube. How do we get this, or how we are converting it into 1000 kg per meter cube? Okay, you need to have a pen and paper with you so that you can copy this what I am writing right now. So if you don't write, it will be very much impossible for you to remember it later, and if you do not practice, physics is not for you. Okay, so let's see how we are converting it. As we know, 1 gram is equals to 1 by 1000 kg. The conversion is complete. Okay, now how to convert centimeter cube into meter cube? Let's write 1 centimeter is equals to 1 by 100 meter, but we don't have centimeter over here, we have centimeter cube, so we have to cube it over here too. So if I do that, it becomes 1 cube and centimeter cube. It also becomes 1 by 100 cube, then meter cube. So it becomes 1 centimeter cube is equals to 1 by 2 zeros into 3, that means we have 6 zeros, 1 2 3 4 5 6 meter cube. Now let's see how the conversion is done. Gram per centimeter cube to kg per meter cube. So gram to kg on numerator, it is 1 by 1000 kg. So let's write 1 by 1000 kg. Centimeter to meter cube, so let's write 1 2 3 4 5 6 meter cube. Now let's calculate 1 by 1000 into 1 2 3 4 5 6, and the unit becomes kg per meter cube. Let's separate this. Now 1 2 3 1 2 3, see, 1000 kg per meter cube. Now this is the conversion process when you are converting a CGS unit into an SI unit. This is how 1 gram per centimeter cube becomes 1000 per meter cube, 1000 kg per meter cube. Okay, now this is the whole process. Now let's take the next numerical example, and the question says a piece of coal has a mass of 40 gram. That means M equals to 40 gram. Okay, and the volume is 30 centimeter cube, and the volume is 30 centimeter cube. Now we need to find the density and relative density. When mass and volume is given, finding density is very easy. That means mass per volume, and it becomes 1.33 gram per centimeter cube, right? Now we need to find out the relative density of coal. So RD of coal, as I've learned earlier, how to find out the relative density? Density of the unknown substance, which is coal over here. So density of coal, which is this, and density of water at 4 degrees centigrade. Okay, now we have known the density of water at 4 degrees centigrade. We have two quantities. The first one is 1 gram per centimeter cube. The first one is 1 gram per centimeter cube, and the second one is 1000 kg per meter cube. Which one to take? Density of water at 4 degrees centigrade. Here the unit takes place. Here the part of unit takes place. You know why? See, gram, centimeter cube, they are the units in CGS system. So we have to take 1 gram per centimeter cube. So density of coal, how much? 1.33, and density of water at 4 degrees centigrade, which is 1. No need to write the units, because we have learned that relative density is unitless. So the final answer is going to be 1.33. This is the relative density of coal. And we have done the first part of this chapter. I hope every part of it you have understood. So if you don't understand any part of it, please let me know. I will definitely try to make you understand this. Okay, thank you for watching. Bye.